Okay, so where was OpenFOAM at the point at the start of this project? I can refer to a benchmark conducted in 2016-2017, where OpenFOAM was run on the Fujitsu K computer on 100,000 cores, and the cell count was 100 billion cells. That was a pretty amazing execution, where we kind of turned off many constructs of the code to get the maximum performance at that moment in time. So we can say from that benchmark, the achievement of the performance of OpenFOAM was somewhere around 0.1 petaflops. And we use this benchmark really on the basis of the assumption that each processor was around 3 gigahertz, and that it would successfully operate 0.3 CFD operations per clock cycle. So that puts us about 0.1 petascale. So it's not that far away from what we would generally consider to be exascale. So that's our data, and this is how we intend to be reaching higher levels, at least one order of magnitude and probably more. Okay, so here's the next slide. Exactly what are we doing and how are we doing it in terms of releases? We continue to want to make sure that every development done in OpenFOAM is done as purely open source. Okay, and open source means what? In general, the open source community with CFD is complementing or competing, depending on which side of the fence you're sitting on, commercial codes which have similar levels of capability. And they have a lot more resources in commercial CFD for developers, support, etc. Not as many as the resources that we are given within the open source domain. Okay, but ever since we started getting involved in GPL version 3 and open source releases coming from ESI and part of the organization that I'm part of, which is OpenCFD, we decided that we would go for ISO 9001 accreditation, which means that the value of the code that we release every 6 months falls under full quality assurance perspectives. So we achieved that in 2018. So every 6-month release has really gone through a very thorough set of quality assurance measures prior to every release. You'll see that part of that quality measures is running very frequent tests. So we have daily tests, we have weekly tests, and pre-release every 6 months, we have a number of benchmarks that we go through to ensure that you get downstream compatibility, what we call regression testing. One of the main impacts of the exaFOAM project is to make sure that the verification of the large test loop is including real industrial benchmarks, which is pointing at continuing the level of performance for HPC in general, not just for regression testing of accuracy of the code. So you hear during the course of the day that there are several benchmarks and sizes of benchmarks included via exaFOAM. The first one of those is what are called micro benchmarks, very small cases that test several functionalities in OpenFOAM. Then the next level is industrial cases. The industrial cases are much bigger cases that may take several hours or several days to run. And then finally, in industrial or what are called grand challenges, of which we have already fine-tuned on 2 and maybe 3 will come up by the end of the project. Okay, so these micro benchmarks, industrial cases, and the grand challenges are something that through work package 2 in this project we're extremely proud of. And it fits in within the general QA testing, which will continue for the long-standing in our release sequence every 6 months for OpenFOAM. Now, what are the technologies that we are targeting? Efficient data structures for sure, algorithmic acceleration improvements for sure, linear solver acceleration using several tools, including different machine architectures and chip architectures, including GPUs, and combining CPUs and GPUs together. Optimization of I/O, the use of external solvers, and as you've heard from some of my colleagues already, load balancing optimization. We are beginning to see several of these already released in OpenFOAM, some of which already came in 2023 and before that, and we'll seek to exploit and release all of the findings in the exaFOAM project during the course of 2024 and even beyond that. So keep watching this space. for the improvements that we've seen under exaFOAM. The final part of our aims is to make sure that European industry continues to be able to explore and exploit exaFOAM computing towards exascale. To do that, we are really relying on the OpenFOAM governance structure. But part of the technical committees includes an HPC technical committee, but also several other technical committees which are looking at numerics and optimization, as I've highlighted here, turbulence, multi-phase, and applications committees as well, which are concentrating on automotive or aerospace or marine, etc. So, we were very pleased to have initiated this project through the promotion from the HPC Technical Committee, and they'll continue to be involved in the further exploitation as we go further downstream in terms of our further exploitation. Okay, so that really was a very general overview of who we are and kind of where we're coming from. Part of the exaFOAM project is looking at the following: not just working collaboratively between the development community in OpenFOAM, but also to make sure that we have very close partnerships with partners in chip manufacturers, machine assemblers, etc. So you can see down there in the list that we work with AMD, we work with NVIDIA, who are now becoming particularly prominent in the GPU space, and we continue to work with other machine manufacturers, Intel, IBM, ARM, but that is supported by the completion of the triangle in terms of our industrial case partners. So automotive companies like Toyota, General Motors, VW, plastics companies like Logoplast, energy companies like Siemens, environmental safety companies like FN Global. So the triangulation here of making sure that the release of OpenFOAM is done in a good way, that we're partnering with our end customers in industry, but also partnering with our partners in the computer industry, is a very solid triangular connection of connections. Okay, so that was really a very brief overview. I've already